Hello everyone, this is Colin from Fiber Optics for Sale. In this video, I will explain what is fiber optic media converter. A fiber media converter is a simple networking device that makes it possible to connect two dissimilar media types, such as twisted pair with fiber optic cabling, as shown in this picture. Twisted pair cable, coaxial cable, and other copper cabling can only support a limited length before signal becomes too weak. On the other hand, optical signal can propagate in fiber cables for very long distance before signal becomes too degraded. So fiber optic cable is used to extend the network from 2000 meters up to 120 kilometers. A fiber optic media converter has two interfaces. One interface is a local electronic interface, may it be a RJ45 Ethernet or RS-232 serial data interface. The other interface is usually a duplex fiber interface with ST, SC, or LC connectors. One of the optic port is the optical transmitter. The transmitter accepts coded electronic pulse information coming from copper wire. It then processes and translates that information into equivalent coded light pulses. A light emitting diode, LED, or laser diode can be used for generating the light pulses. Using a lens, the light pulses are coupled into the fiber optic cable and transmitted down the line. Once the light pulses reach their destination, they are channeled into the optical receiver port of the media converter on the other end. The optical receiver converts it into an electronic signal containing the information coded on the light at the transmitting end. There are many advantages of using fiber optic media converters to extend your network. Fiber optic signals are immune to RFI, EMI, and ground differential. They support very long distance, from 2000 meters with multimode fiber up to 120 kilometers with single-mode fiber. So fiber optic media converters are ideal for commercial and industrial environment, such as shop floor and substation environments, where EMI and RFI can be a serious problem. For this reason, engineers are now using fiber Ethernet to extend transmission distance and protect data from the effects EMI, or even gigabit Ethernet to provide increased bandwidth. Fiber media converters support many different data communication protocols, including Ethernet, Fast Ethernet, Gigabit Ethernet, T1, E1, J1, DS3, E3, serial data links such as RS-232, RS-422, RS-485, USB, plain old telephone service, or general-purpose media converters which can support HDTV, MPEG encoder, video on demand, etc. In the market, there are two basic types of media converters. A true media converter basically converts communication on a bit-by-bit basis. After one bit is received, it is transmitted in the other format, copper or fiber optic. This is in contrast to a switch, which receives the entire frame of Ethernet before forwarding can begin. A non-true media converter or switched media converter is simply an Ethernet switch that contains an RJ45 port and one fiber optic port. This media converter will wait for an entire frame to be received before forwarding can begin. There are a couple problems with non-true or switched media converters. The first problem is increased latency. The other problem is when using switched media converters in redundant systems such as IEEE 802.1d RSTP. Many media converters on the market today are switched media converters. One very important reminder, you should almost always use media converters in pairs from the same brand and the same model. Consider what happens if the copper cable connecting the switch on the left with the media converter gets unplugged unexpectedly. In this case, the switch on the right will have no idea what has happened, and even though the connection has been disconnected, the network will continue on its merry way, assuming that the connection is still viable. This is where link fault pass-through comes in. The detailed operation of link fault pass-through is illustrated in the right figure. Image 1 shows normal operation of the two media converters. Image 2 shows copper cable to converter A gets disconnected, and image 3 shows converter A disables the connection to converter B. Image 4 shows converter B disables its copper connection, and image 5 shows converter B disables connection to converter A. In the above illustration, we showed media converters being used in pairs. In fact, most vendors illustrate link fault pass-through with two media converters used in pairs, as they well should. But nevertheless, many engineers disregard this point and use only one Ethernet to fiber converter. The problem with using only one media converter is that if the media converter's far-end fault and link fault pass-through functions are activated, the functions will not work properly. Not only should the media converters be used in pairs, but in addition, you should also choose the same brand and same model. This is because Different vendors could use proprietary protocols to run far-end fault and link fault path through. In fact, the same vendor could use different converter ICs in different models, which will result in the different models being incompatible. So there you have it. Please leave a comment below if you'd like to see other topics. Don't forget to visit f4forsale.com for more free fiber optic tutorials. I will see you in the next video.